Just big.
Section 2, translation. Translation is a transformation where all the points of figure are moved the same distance and same direction. Okay. One of the key aspects is the orientation and size will remain the same. It is almost like just the object has shifted over. Okay. So the first, the guy in the car translation, the flower translation, the puppy is not a translation because the orientation is not the same. Okay. The fish is not a translation because the size is not the same. Okay. Translation will keep the same orientation and size. Okay. All transformations outside dilations, which I don't think we're going to talk about, but all transformations should keep the same size. Reflections and rotations will change the orientation, but translation will be the one that keeps it. So, now we are going to talk about the change from J to J prime. Now J is at -4, -2. J prime is at 1, 1. K is at 0, -4. K prime is at 1, 2, 3, 4, 5, -1. L is at -4, -5. L prime is at 1, -2. So what I want to know is what is the change in X and the change in Y. So from -4 to 1, what is the change? Is it up or down? So up by how much? All right. From -2 to 1, it is up by how much? 3. So that is our transformation. If you see each of these, from 0 to 5, it is up 5. -4 to -1, up 3. -4 to 1, that is up 5. From -5 to -2, that is up 3. So my rule for transformation, or translation for this, would be I take the X values and I add 5. I take the Y values and I add 3.
What if it's a -3? Would it still be addition or would it be subtraction?
It would be subtraction. Yeah. So another way to write this now, I don't think we've ever talked about vectors. Have you guys ever talked about vectors?
No.
Vectors are written with this weird kind of shaped parentheses that are more pointed. Okay. And it is all about change. Vectors represent change, movement in your X and your Y. So a vector would really be, again, delta X, comma, delta Y. Is that change in X, change in Y? So we already know the change is 5, 3. Now, again, if it is a decrease, it would be a negative value. I do not know why my values are doing this, but let's see, it's probably on the next page. Yeah, there it is. All right. Now, we are going to translate this 1 unit to the right and 4 units up. Now, that means I'm going to add 1 to X and add 4 to Y. So if I add 1 to X here, my A prime is going to be at 2. If I add 4 to -3, I'm going to get 1. So 2, 1 will be A prime. If I add 1 to 3, I get 4. If I add 4 to 0, I get 4. So 4 be my B prime. If I add 1 to 4, I get 5. Add 4 to -2, I get 2. So 5, 2 be the C prime.
So the translation could be written as 1, 4.
The translation written as 1, 4. Yeah. Now, for those, if you were not here yesterday, when we translate a shape, the new name for the shape is the same letters. We just include an apostrophe, and the apostrophe we call prime. So we go from A to A prime, B to B prime, C to C prime. The original, the pre-image is your ABC. The new image, or what the result is your prime. All right, so here they just want us to create the general rule. Okay, so we can do this a couple ways. One, we can list it out. So we know M, that is at -4, 0. And M prime is at 3, 2. So what's the change from -4 to 3? Sorry, that's -3, not -4. My bad. So a change from -3 to 3 is what? 6. And a change from 0 to 2 is 2. Another way to do it is just to make the triangle. The change in x, if I go over 1, 2, 3, 4, 5, 6. So this changes 6, and that changes 2. It's just to draw it out in the graph. What is the movement, left and right? So I'm adding 6 and I'm adding 2. So you can either write down the coordinates and look at the change that way, or you can just look at the change on the graph. Pick your way, I'm not going to care. So we are given the quadrilateral. Now, I know we haven't really talked about quadrilaterals, but a quadrilateral is a four-sided geometrical figure. The points of this quadrilateral are A, B, C, D, where A is at 0, 2, B is at 3, 4, C is at 4, 2, and D is at 3, 0. We're going to do a vector change of -2, 3. So we're going to let's just do this easily. Let's look at all the x values and subtract 2. So A prime is going to be at -2. I'm not going to worry about y. I'll do y in a second. So B prime, my x value is 1. C prime, my x value is 2. And D prime, my x value is 1. So all I did was I took away 2 from each x value. The y values are going to increase by 3. So for A, if I increase 2 by 3, I get 5. For B, increase 4 by 3, I get 7. C, 2 plus 3 is 5. And 0 plus 3 is 3. Transformations, by the way, translations are the simplest types of transformations. To be honest, I kind of wish we had done this tomorrow. If I really thought this through, we could have done this tomorrow. It would be a whole lot easier to do this on the short Wednesday, but what are you going to do? We have Thursday as a review day, so if we don't finish rotations tomorrow, we'll finish on Thursday and then do the review. I suppose a second translation is applied to quadrilateral. Now, here we have a second translation. All right, that means we have an A double prime, B double prime, C double prime. We don't do prime prime. That doesn't make sense. So that's how it's called: double prime, triple prime, so on and so forth. So let's see what the change is from A to A, or A prime to A double prime. So if I go from -2 to -3, what's that change?
With A prime to A double prime?
Yep.
Oh, I thought it was A to A prime, A to A double prime.
No, just from A prime to A double prime. So what is -2 to -3? What's that change?
-1.
-1.
Oh.
All right. And then from 5 to -3, that's down quite a bit. What's that? -8. So let's make sure that's the same for each of these, just to make sure. If I take away 1 from 1, I get 0. So good. Take away 8 from 7, I get -1. Take away 1 from 2, I get 1. 5 minus 8 is -3. 1 minus 1 is 0. And 3 minus 8 is -5. So yeah, that works. All right. So right a rule that describes the translation shown on the graph. Now, we do not have to find every coordinate. We just are doing more of the what is the change. So let's just pick an easy point, D and D prime. Now, since it is going to the right and up, both my change will be positive. How much to the right does it go? 4. How much up does it go? 1. There you go. Now, D to D prime here is going to the left, which means it is going to be negative. But it also doesn't go up or down, which means my change in Y is 0. So how much to the left does it go? 1, 2, 3, 4. So -4, 0. And that is the lesson. So if you want to go ahead and get started on the homework, go right ahead, get that done. If you want to show me the homework from yesterday, now is a good time to do that.
Yeah.
It's the whole packet, yeah. All right. Check. Motion numbers. Okay. Yeah, good. So they are live. Thank you very much. All right.
Well, I skipped it too. Do you have an extra note packet? And I would assume this is
Packet over here. I have a note packet right here. Make sure I didn't give you too many homework packets there because I put sticking together. There you go.
After I finish the 2 homeworks, can I go to the library?
Yeah.
Mm.